Okay. So we're asked to use Green's theorem to find the work done by the force F of x and y is equal to x plus y in the I direction plus xy squared in the j direction. In moving a particle from the origin along the x-axis to the point 1, 0, then along the line segment to the point 0, 1, and then back to the origin along the y-axis. So here I have drawn my path. We're going from the origin to the point 1, 0, then from this point to the point 0, 1 along this segment, and then back to the origin along the y-axis. And we have here our orientation going positive. Now we're asked to use Green's theorem, which we have here. P dx plus q dy is equal to the double integral over the region of the partial derivative of q over x minus the partial of y over the partial of p dy, and then we have dA. Now to evaluate this problem, we'll need to know the equation for this line segment right here, which we can find by either just using the slope formula and finding the slope of the line, and then just using the y-intercept to find your b, which is, I'll guess, m is equal to rise up or around. So we have the point, 2 points, so y 0 minus 1 over 1 minus 0, which is just negative 1. So this is your slope. You have y mx plus b. You have your m negative x plus b. Now you just find your b with your y-intercept, which is going to be 1 times 0 plus b, so b is 1. Now we know that the equation for that line is going to be negative x plus 1. Now we have our force is given, and we know that this is just a dot product of dr. We know that dr is going to be dx in the I direction plus dy in the j direction. So when you dot that together, you're going to get the line integral positively oriented of x 180 x plus y dx plus x y squared dy. Now this is going to be your p, and this right here is going to be your q. Now we should use Green's theorem to find the double integral over a region of q with respect to x. So that's just going to be y squared minus your p with respect to y. So p with respect to y, we write this as x squared plus xy squared xy. This is going to 0, and that's just going to be y. And dA, we can either choose to do over y or x first. I'm going to choose to do y. So now we should enter through 0 and exit to y is equal to negative x plus 1. And then our x limits are constant, which is going from 0 to 1 dy dx. Now we just do take the derivative of that, and we'll get 0 to 1 of y cubed over 3 minus y squared over 2, evaluated from 0 to negative x plus 1, and then your dx. So that's going to turn into 0 to 1 of negative x plus 1 cubed over 3 minus negative x plus 1 square over 2 dx. Now to evaluate that integral, you can break it down into two different integrals, so it's easier. And you can take the constants out. So the first one is going to be 1/3. It's 1/3 times the derivative of negative x plus 1 cubed dx minus 1/2. This is a derivative of 0 to 1 of negative x plus 1 square dx. Now we can do this by use substitution for both of them. and you're gonna let u equal to negative x plus 1. So now du is going to be negative dx. So we know that negative du is equal to dx. And this is going to work for both of them in this case. So we will do the same thing for the other one. Now we have 1/3 times the derivative of u cubed. U cubed. I usually like to change my integrals, so I'm just going to change my integrals. If we put 0 for x, we're going to get 1. If we put 1 for x, we're going to get 0. Du, let's just write that, okay. U cubed du minus 1/2, again, same limit, so 1 to 0, u squared du. So now this is negative. This is a positive. Sorry, so since du is negative, negative times negative times the positive is going to be negative out here, and then the negative times this negative, we'll get a positive. Now I'm gonna change the limit so that the zero is on the bottom, so it makes it easier for me. So it will be positive 1/2 from 0 to 1 of du cubed du minus 1/2 from 0 to 1 u squared du. Now we just integrate 1 cubed u to the 4th over 4th from 0 to 1 minus 1/2 u cubed over 3 from 0 to 1. Now plugging back into that one, we'll get 1/3 times 1/4 minus, plug in the 1 into here, 1/2 times 1/3. And that's going to be 1/12 minus 1/6. So least common denominator is 12. That's 1/12 minus 2 12s. And then our answer is negative 1/12. That's how you use Green's theorem to find the work done.